Welcome to another edition of Technician's Toolbox. This series of videos will focus on the electronic throttle control system. Once used on luxury vehicles for traction control and reduce engine and transmission feel to the driver, electronic throttle control is now used on almost every new vehicle manufactured today. While the system reduces the parts count in auxiliary systems like cruise and idle controls, the real driving force is fuel economy and emissions. Without ETC, the advances in hybrid and diesel technology being used today would not be possible. In these new systems, the accelerator pedal sensor is an input not only to the engine control system, but to the software system as a whole. The pedal angle or driver input is used to control engine output and by other electronic control systems. The software controlling the anti-lock brakes, vehicle stability, cruise control, HVAC, and other system functions all use pedal angle data in a decision-making process. Throttle angle that results is not only what the driver wants, but what the system needs for correct and safe operation. The major cause of reduced engine efficiency at low engine RPM is from pumping loss. Traditionally, reducing the output of an engine is accomplished by limiting the airflow into the engine. The throttle plate restricts the intake of air by forcing the engine to drag air through a narrow or restricted inlet. Restriction of the air intake creates a pressure drop across the throttle plate. Most technicians refer to this as intake manifold vacuum. Since the air entering the cylinder is now below atmospheric pressure, less air enters the cylinder. On a speed density system, the engine control system measures the pressure differential and reduces the fuel input accordingly. The reduced quantities of air and fuel result in the desired reduction of power output. The negative factor is that partial pressure or vacuum in the intake manifold wastes energy. As the piston moves downward on the intake stroke, normal pressure below it and partial vacuum above it cause drag on the rotation of the crankshaft. These pumping losses occur during most engine operating conditions as the throttle is rarely wide open. Diesel engines are known to be approximately 25% more efficient than gasoline engines. One reason is that the diesel engine has no throttle. The gasoline engines, the throttle-related losses are estimated to be in the range of 7 to 10%. PCM could be programmed to reduce the fuel mixture and timing so the driver needs to depress the throttle further to achieve the same speed and reduce pumping losses. However, this would not be accepted by the vehicle owners because the vehicle response would not feel right. With ETC, software can compensate for the throttle angle to maintain the original pedal-to-throttle relationship the driver is accustomed to. ETC can also be used to control actual throttle angle during acceleration and deacceleration to minimize pumping losses. Often, the throttle angle implemented by the ETC system could be more favorable than the driver is able to select. Electronic throttle control can also be used to protect the engine, driveline, and tires from operation that may cause excessive wear or damage. Rev limiting can be accomplished in software by governing the throttle angle rather than cutting fuel or reducing ignition timing. This results in a much smoother limiting that does not cause the driver to sense that the engine has cut out, as can be the case with ignition timing and fuel-based limiting systems. Over the next few episodes, we're going to cover manufacturer-specific ETC systems with an explanation of how they operate and some possible case studies. Please check back for the next Technician's Toolbox video covering electronic throttle control systems. Thank you.